All right, so in this video, we're going to use the wave equation to solve some problems. And the wave equation basically says that the speed or velocity of a wave equals its frequency times its wavelength. And typically, velocity is going to be in meters per second. Frequency will usually be in hertz, which is the same as inverse seconds, or seconds negative 1 is inverse seconds. And wavelength will usually be in meters. Now, if these are not in these units, this will not be so straightforward, but I'm just going to stick to these units for now. So when you multiply meters by 1 over seconds, you get meters per second. That's sort of how this plays out. So the way you start these problems is you want to identify what are you even being asked. You want to identify the question. So this is saying what is its wavelength. So the variable we're looking for is wavelength, and I'm just going to write wavelength equals question mark. And then we want to figure out what else we know. So it comes out and tells us our frequency. So I'm just going to write F equals 30 hertz. And it comes out and tells us the speed is 720 meters per second. So now once you know what you're looking for, you know what you have, you can look at your equation and substitute in. So I know V is 720. I know F is 30. And I do not know lambda, wavelength, so I'm going to leave it like this. So I'm just plugging in what I know. And then I want to solve for wavelength. So to get wavelength alone, if I divide each side by 30 here, then I'll get that the wavelength equals 720 divided by 30, which should be, I believe, 24. And it is. And the units are important. This is a wavelength, which is a distance, so it should be 24 meters. And now that's good. We should always double check, though. We know this equation is correct. This came to us. It is a definition. So once you have your answer, you should just do a quick check. Does frequency times wavelength equal velocity? So does 24 times 30 equal 720? And if you plug that in your calculator, it will check out. So that means you probably did the algebra right. This is a good thing to do at the end. So let's look at another one. So again, start by figuring out what am I looking for. Look for the question. What is its frequency? So I say, I'm looking for F. What do I know? I know the speed is 20, so V is 20 meters per second, and I know the wavelength is 80. Then we're going to take our equation, so V equals frequency times lambda. We're going to sub in, so I know V is 20. I do not know frequency, so I'll leave that as F, and I know that lambda is 80. And I want to isolate F, so the only way to get F by itself is if I divide both sides by 80. So 20 divided by 80, I get 0.25. And this is a frequency, and if I've used all the standard units, I will get frequency of hertz. So 0.25 waves every second. And again, I just want to double check, does this make sense? Does F times lambda equal V? So this 0.25 times 80 give me 20, and in fact it does. So it means I probably did my calculation correctly. Let's do one more that's a little trickier. So in this situation, again, always start, identify the question. What is their wavelength? I need to know this. Write it down with a question mark. What do you know? Oh, they gave me speed. Speed is 20 meters per second. You might remember the equation is V equals frequency times lambda. So if I want to find lambda, I need the frequency. They don't come out and just give you the frequency here. You have to figure it out. So that's the difference in this problem. So you say in 40 seconds, 10 waves pass by. So you have two options to find the frequency here. One way is to find the period. The period is how many seconds per wave. So in 40 seconds, if 10 waves go by, then your period is 4 seconds. That means you're getting one wave every second. And once you know the period, we have an equation that says the inverse of the period is the frequency. So it's just a matter of saying 1 over 4, which is 0.25 is the frequency. Alternatively, you could have realized that I'm talking about frequency. Frequency is how many waves per second. So in 40 seconds, if you only see 10 waves, hopefully you notice that that's less than 1 wave per second. So we typically are going to have to divide one of these numbers by the other. The question is which way. So to find period, we took our total time divided by how many waves to get our period. To find your frequency, you're just doing the opposite. There were 10 waves in 40 seconds, and so that means your frequency is 0.25. So it doesn't matter which way you go about finding your frequency, whether you find the period first and then adjust, or whether you just dive right in and find the frequency. Doesn't really matter, but you do need to find the frequency. So now it's just a regular problem. I've got my frequency, I've got my velocity, let's plug in. So I know that V is 20, I know my frequency is 0.25, and I know my wavelength is unknown, so I want to divide each side by 0.25 to find my wavelength. So 20 divided by 0.25 is going to be 80. So my wavelength should be 80 meters. And again, just double check that. Does 80 times 0.25 give you 20? It does. So that works out. So that's the process you should follow. Always start and do this. And this is going to help you solve a lot of different physics problems, not just wave ones. A lot of physics problems involve some type of equation that you're solving one variable for. And so if you follow these steps of identify what you're looking for, identify what you know, plug in, solve, check, this is going to take you pretty far with these types of problems. Okay? So until next time, I am Derek Genova. Have a delightful day.